Hi everyone, and welcome to this lecture. In this lecture we are going to talk specifically about particles and the population, how we can represent them. So here I'm going to give one example of how we can represent the particles of this problem. This is not the only possible representation, but this is what we will use in our project. So here we have the following structure. Each particle is composed of three pieces of information: the previous position, or pos 1, current position, or pos 2, and the velocity val. So here we can see a nested list with three lists inside it. Here we have position 1, position 2, which is the current position, and the velocity. The positions of each particle will be vectors whose size can vary depending on the dimensionality of the problem. So here you can see that for each small list here, we have only two elements or two indices. In this case, this hypothetical problem has a dimensionality of 2. Since we are dealing with 6 variables, the number of hours in the morning of Sunday, the number of hours in the Monday, in the afternoon, and so on, we will have 6 indices in each of these sublists right here. Let's suppose that here we have another example. Let's suppose that I want to optimize this function 2 squared plus y squared. What is the dimensionality of this problem? How many variables do we have? 2. So the dimensionality of this problem is 2. And here we have a population of particles. In this case, I'm going to create several of these particles, each one of them having the first position, the second position, or the current position, and the velocity. And within this population, we'll have the best particles and the worst particles. In the next lectures, we'll see how we represent and how we find the personal best and the global best particles.